Okay, everything should be good to go now.
Okay, thank you. Hi, welcome everyone. I'm Helen Palmer. I'm a senior scientist at the Department for Architecture Theory and Philosophy of Technics at TU Vienna with Vera Buhlmann. And firstly, I'll just say a few quick words about the School of Materialist Research, SMR. This is an education and research collective that offers intensive study courses, seminars, special programs and research initiatives that address the materialisms running through contemporary science, philosophy, art, mathematics, design, architecture, and politics. SMR was founded by the Center for Philosophical Technologies at Arizona State University, the Institute of Social Sciences and Humanities Skopje, the Department for Architecture Theory and Philosophy of Technics at TU Vienna, and the Critical Inquiry Lab at the Design Academy Eindhoven. And it serves as a global hub for education, research, and experimentation at the intersection of the humanities, social sciences, creative fields, and the STEM sciences. So this evening, we have the final talk from our special program organized by Vera Buhlmann for essays on the architectonic body. And we have with us this evening, Philippe Morel. Welcome, Philippe. I'll just say a couple of words to introduce you. Philippe Morel is an architect and theorist, co-founder of EZCT Architecture and Design Research, and initiator and founding CEO of the large-scale 3D printing corporation X3E. And he's currently a visiting professor at UCL Bartlett and an associate professor at the École Nationale Supérieure d'Architecture Paris-Malaquais. Sorry for stumbling over the French, where he headed the Digital Knowledge Department, co-founded with Pierre Girard. Philippe's book, Empiricism and Objectivity, Architectural Investigations with Mathematica, subtitled A Coded Theory for Computational Architecture, is to be considered the first architectural theory book entirely written in code. So I will leave the rest for you to talk to us. Philippe, the floor is yours.
Great, thanks a lot. Thank you, Vera, and you for Ellen for the invitation. I'm really happy. First, I also apologize that I had to postpone this lecture, but I'm really happy to be with you today. So let me share my screen and start. Okay, so yes. Okay, now you should see my screen. Should be good. How can I remove that? I don't know if I can remove this. Do you know if it's possible to remove this window here? I mean, this bar.
I'm not entirely sure, to be honest. What's the exact problem?
Do you see the control bar of Zoom?
No.
On your screen? You don't see it?
I don't see it,
so
no.
As long as you don't see the control bar from Zoom, then it's okay. So you have an introduction page without nothing. It's just a clean slide, right?
Yep.
Okay, perfect. Okay, so excellent. Okay, so let's start. I will discuss today the issue of matter. As the title indicates, I will speak of matter as machine. Let me start with this about the 20th century. So 20th century is characterized by the end of classical mechanics, by the birth of a new mechanical abstraction, which in fact is computation, and by the fading of materialism, whose golden age is the 19th century in favor of what I called, quite a long time ago, a linguistic turn of production. That linguistic turn is dominated by logic mathematical languages, in fact, formal languages. There has been a few attempts to revive materialism, most recently in architecture through the concept of material computation, for which matter analogically computes analog results. It seems to me that this approach misses the point, as matter is a machine that computes through any kind of paradigm, analog or digital, binary or not, according to the linguistic model one embeds in matter or into the matter. So if we look at the 20th century, if we pay attention to this end of the mechanical era, it was very well exemplified by this exhibition at MoMA in 1968, entitled The Machine, or the Art at the End of the Mechanical Era. It was, by the way, organized by Pontus Hulten, who was to become the first director of the Centre Pompidou in Paris, right after it has been opened. So, in fact, this end of the mechanical era, it coincided with some movements in art that are also exemplified exactly in the same year in 1968 in New York by two exhibitions, Cybernetic Serendipity and Some More Beginnings, an exhibition of submitted works involving technical materials and processes by Experiments in Art and Technology group. It was a research group made of artists, but also scientists and engineers and technologists. All of that, in fact, was, let's say, testifying or indicated that we were to enter a new era in the 20th century society. In fact, the era of software and the era of information. Information in art, strangely, it came slightly after the introducing of software or technology, digital technology, which at some point is a bit weird, but information was more associated to abstract and conceptual art. For example, this exhibition that was organized in '97 at MoMA in New York, it was not so much about the computer, but it was very much about conceptual art and minimal art. Let's say the idea of information was associated with concepts and I would say linguistic, while the idea of software was associated with the computer in itself. While in fact, of course, information and software and all of that share some common characteristics. Information was theorized in a very rigorous way, by Claude Shannon, as we know. And right after the Second World War, it was also used as a concept in the famous work of Norbert Wiener, in the cybernetic theory. So in 1948, we really experienced the birth of the Society of Information, which was a kind of conjunction of different moves, different let's say evolutions and discoveries and inventions. The theory and techniques for design of electronic digital computer by von Neumann, the mathematical theory of communication by Shannon, but also the cybernetics by Wiener. These three books or papers, technical papers at some point, are absolutely amazing, and it's quite fun that they all appeared the same year They really forms a kind of triad of the foundation of the society of information. So the society of information was soon going to colonize everything, including industrial production. But what I want to point out here is that information comes, or let's say it came first as a linguistic concept, and then as a mathematical quantity or as a mathematical concept. I insist on the issue of quantity because this is what really helped creating the modern definition of information, at least according to Shannon. I mean, quality was not important, it was irrelevant, while quantity was, of course, the key aspect of Shannon's theorization of information. So this information was also associated with machines at some point. It was associated with machines, for example, when it was about transmitting codes. Think of the Morse transmission machine, Morse code transmission machine. But of course, it was also associated with computing machines that were first not completely digital, not fully digital. They were electromechanical machines, like this Burroughs machine. And later they would become digital, including within the Burroughs company, which was a brand. But it's kind of fun to think of Burroughs as a writer. We know, of course, William Burroughs. We know the famous author of The Naked Lunch. But I believe that the fact that he was a grandson of the founder of the Burroughs computing machinery company had a very strong influence on the way he conceived, let's say, life as a whole, and of course the human body as well. So it really insisted on this issue of a soft machine, and he was at some point he was really well situated to know about the evolution of the machines at that time. Oh, sorry. So when we think of that, the soft machine is a post-mechanical machine where software dominates hardware, either the mechanical components in electromechanical machines or the transistors in fully digital machines. So here it doesn't really matter if the machines are electromechanical or fully digital. At some point, what matters is the opposition between the software part, and the hardware part, which is in any case physical. It's made of matter. Even transistors are made of matter. So this is what why I insist on this distinction. So on one side we have the language. On the other side, we have the matter, the material. So this language issue, the software, is definitely a linguistic issue, and just to be 100% sure of that, we just have to think of the programming languages, Fortran, that are 100% linguistic, and it has nothing to do with the physical matter that will compute the instruction of such a programming language like Fortran. But of course, I mean, what applies to Fortran applies to any other kind of programming language. If we look at the work of Negroponte in 1968, Negroponte was also using this term, soft architecture machine. He put the architecture word in this, but in the title. But obviously, Negroponte was also not very much interested in the physical realization. He was very much interested in the software part, in the linguistic part of what can be done with the new machines we are speaking about. More or less at the same time, other architects including David Georges Emmerich, who was teaching in Paris at the École des Beaux-Arts, was also interested in the issue of software in a slightly different way. For example, here in a bulletin that was published in a review called AMC, Architecture Movement Continuité, Architecture Movement Continuity in the France number. You can see a couple of diagrams by Emmerich, and Emmerich is directly referring to the printed circuit that are the, let's say, yeah, at some point the material part of the computer. I mean, the parts that are made of matter. And Emmerich is really trying also to merge what is on the software side and what is on the hardware side, but he doesn't pay so much attention to the linguistic aspect of the computer. He mostly pay attention to the material component of the computer and the printed circuit here, because he believes that at some point what we should learn from the computer is not so much about the software, but it's about the very, let's say, light and elemental material nature of the computer. I mean, the fact that we need only very little material to reach important results. So Emmerich was not the only one working in that direction. He was forming a team, let's say, with Le Ricollet, Chassagnou, Makarios, and probably the most famous is Konrad Waxman, who was also working on this thing. Here at the Unité pédagogique d'architecture, numéro 6, so pedagogical unit of architecture number 6 in Paris. So what you see in the world of Emmerich was an attempt to redefine the discipline of architecture, not based on the linguistic model of the software, but based on the economy of material that is implied in a new in a new sort of machines, the computers, which are of course making a much more economical use of matter compared to the old mechanical big machines of the 19th century, for example, the steam engine and all this kind of massive machinery. So Emmerich wanted to follow that, and as you see, in fact, these projects are not linguistic at all. They are completely based, again, on the model of the computer, but not the linguistic model of the computer, but the material model of the computer, which is using, as I said, very little materials to produce absolutely mesmerizing results. In fact, computation. But Emmerich was also paying attention to what happened in nature, and he was one of the architects who was constantly making a parallel by, I mean, between how nature is using material with a certain kind of economy of needs, and how the computer is using the material. For him, it was very similar. But in any case, the software superiority has been unconsciously acknowledged everywhere, from linguistic to architecture to art. But I believe that apart from a couple of architects like Emmerich, it was mostly the linguistic model of computation that became dominant at that time in the 60s. If we look at what happens in art, for example, with art and language, it's absolutely obvious here that what dominates the discourse is not the matter, but it is the language. It's not the material nature of art, but it is the conceptual nature of art which really matters at that time. And if we look at what happens in architecture, I mean, in the late 60s and 70s, for example, here with Peter Eisenman and its famous notes on conceptual architecture, what we see again is that the linguistic model of architecture, which of course is informed by what happened in the computing industry, is dominant. So again, here we see the linguistic taking over the material in architectural discourse. It's the case also with Cedric Price, with the generator and with a couple of other projects. It's also the case with some more abstract Japanese architecture here, and also the case with George Steiny and James Gibbs in the kind of pioneering book Algorithmic Aesthetics in the mid of the 70s. Of course, this work is also based on the shape grammars, but I mean, as the name, I mean, it's a self-explanatory name. You know, it's shape grammars, which means that it's grammatical, it's linguistic. The way we will build this on a physical level is not that important at all. When we look at the work of Manfred Mohr, for example, and a couple of other artists doing computer art in the late 60s or early 70s, what we see again is also a lot of attention paid to the form, I mean, some of them reminding Kandinsky. Obviously, here it's a drawing by Kandinsky, and in fact, again, the question of matter is not really addressed when we look at more maybe a bit less experimental architects like Richard Mayer. Also, the form, let's say the matterless architecture is important. Everything is white. The material nature of architecture is to be erased at some point, or at least hidden behind white constructions that only insist on their formal nature. It's a case also with Solewit, variations of incomplete open cubes here, but also again with Manfred Mohr. And what we see here is that it completely reminds us what happens with the Boolean table, with a truth table. And in fact, this work of Manfred Mohr is actually based on the truth table. So it's nothing else than a formal visualization of different options that are the direct consequences of the application of truth tables. So and here it's another way of visualizing basic logical rules.
Ich mache ihn dann auch manchmal los, wenn so jemand zum Spielen trifft. Aber jetzt
sorry.
Zu spät.
Oh, sorry. So here you hear me, right? Because I was hearing someone talking, so I wonder if it's okay.
I think it should be fine now.
Sorry?
I think it should be fine now. Somebody had the microphone on.
Oh, okay, no problem. So basically, if we address what happened after the Second World War in art and architecture, except for a few movements like Arte Povera in Italy, and you know, of course, there are always some attempts to revive materialism in art, but I would say that the art of the second half of 20th century is largely dominated by abstraction, conceptual art, and linguistic-based experiment. It's true also for Peter Eisenman, either the first Peter Eisenman or the second Peter Eisenman in the 80s, and it's also true for other architects like Bernhard Tschumi here, for example. So when we look at the relationship between matter and materials, what I could say is that at some point there is an opposition between materials and matter. It's obviously not the same thing, and in fact we have a tendency. I mean, not me, but there is a tendency in the society at large to associate material with effectiveness, effectivity, and at some point also capitalism, for example, and to associate matter, as long as it is not shaped, let's say, to associate matter with a certain kind of resistance, with a certain kind of political loading at some point. I mean, yeah, it's and it was extremely clear in this famous exhibition at the Centre Pompidou called L'Informe, the Formless, that was organized in the 80s by Yves Alain Bois and Rosalind Krauss. Rosalind Krauss was theorizing. I mean, she was a famous theorist of minimal and conceptual art, but at some point she turned into an analysis of the material-based or matter-based arts more precisely. So matter is associated with facts. It is associated with Marx's dialectical materialism. It's associated with what can be reduced to logic, what can't be reduced to mathematics, to formula, to rationality, to mechanisms, or to automata. It is associated with the body, with sensuality, with nature, with freedom. When we look at what was happening at the Bauhaus, for example, the people were constantly paying attention to matter and materialism. And for example, when Hannes Meyer was directing the Bauhaus, he was really constantly insisting on the dialectical relationship that we should constantly consider between form and matter, so that we can, let's say, create a new materialism and a neue Gestaltung, a new, let's say, perception of what is happening of the world. It's true, even in the most formal work at some point, and it was even more true later when Hannes Meyer was about to escape Germany and to teach in USSR, in Russia. So matter is at some point taking over form, especially here in this in the discourse of Yves Alain Bois and Rosalind Krauss, the formless. Here matter is dominating. It was obviously based on this work. Sorry, I'm losing my my words, but from Bataille, yeah, sorry, excuse me. So it was obviously based on the work of Bataille, which at the beginning of 20th century and in the 30s was publishing documents. So Georges Bataille became at some point one of the proponents of a new kind of materialism that should not pay attention only to form, but also to matter. But strangely, when he paid attention to matter, ultimately he kept referring to the form, because the formless is not 100% about the superiority of matter over form. It's still about form, but just a kind of different form, a form that would be non-rational, a form that we cannot mathematize. Of course, at that time, it was not easy to mathematize, to transform into mathematical formulas, complex organic forms. But in the 80s and 90s, it became extremely easy with NURBS-based software and any kind of software that would implement new kinds of approximation, mathematical approximation tools like the Bézier curves and the Castelgeot curves and etc. etc. So for Bataille, the formless is a word whose job is to declassify and do logical and categorical thought, to cancel the opposition on which this thought is based, figure and ground, form and matter, form and content, interior and exterior, masculine and feminine. So this is what Bataille wrote in the Formless in 29, sorry. And later he said, because he referred also to the concept of dictionary in order to exemplify what he had in his mind, he said that a dictionary begins when it no longer gives the meaning of words, but their task. Thus, formless is not only an adjective having a given meaning, but a term that serves to bring things down in the world, generally requiring that each thing have its form. What it designates has no right in any sense and gets itself squashed everywhere, like a spider or an earthworm. In fact, for academic men to be happy, the universe would have to take shape. All of philosophy has no other goal. It is a matter of giving a frog coat to what is a mathematical frog coat. On the other hand, affirming that the universe resembles nothing and is only formless amounts to saying that the universe is something like a spider or spit. So as we can see here with Bataille, the whole issue of the formless is, let's say, to de-rationalize the concept of form, to remove the, let's say, the linguistic nature of form, because as long as we can give a definition, then at some point the form becomes a kind of linguistic issue and not a formal issue anymore. And if it becomes a linguistic issue, then probably it can also become a mathematical issue or maybe a formal language based issue. It can become defined with formal languages. At some point, this is exactly what happened at the end of the 20th century, when any kind of forms, including the most complex and the most formless, at some point became representable through mathematical formula. It's exactly what happened in what Mario Carpo is calling the first digital age in the 1990s. So in fact, this distinction between form and matter was a big problem. Well, it was a big issue. And especially in the left wing thinking, what we have a tendency to associate also with some sort of materialism. People absolutely wanted, let's say, to keep a certain homogeneity, to keep a certain dialectic or dialogue between form and matter. This is what Michael Hayes said in Progressive Architecture in '95. The presumption that a concern for form entails a lack of concern with social issues is worse than conceptual error. It is a pernicious reaffirmation of the classical bourgeois incapacity to think in other than the most compartmentalized and undialectical categories, such as form or content, fact or value, real or conceptual. So in fact, the formless is in favor of a materialist approach, even if, as I said, it's quite strange because just by stating the concept of the formless, we refer to the concept of form rather than to the concept of matter, you know. So at some point there is a kind of contradiction here that we need to acknowledge. So the formless is in favor of a materialist approach, or in any case, it should be considered as a critique of modernist formalism. And this critique of modernist formalism, we saw it in the Italian avant-garde movement of spatialism, for example, which later influenced, as I said before, the arte povera in Italy. It also had an influence on Robert Smithson, for example, here with this conceptual art piece, where he made use of glue and different kinds of material. But when we look at what happens in architecture, even in the let's say most materialist architecture, for example, this one here of Le Corbusier, who invented brutalism, we cannot detach ourselves completely from the issue of form. And it's also the case here with Sainte Bernadette, this absolute masterpiece by Claude Parent and Paul Virilio that was built in Nevers in France. So as I said, in the brutalist architecture, I mean, the concept which is supposed to be put, let's say, forward is the issue of material, but ultimately it turns that we have to consider brutalism as a very formal exercise, and it's also why at some point brutalism failed, at least according to Robert Venturi, because the form of brutalism was not in line at all with what was happening in the society at large, mainly the revolution of communication and information. So our relation with matter and material is complex and ancient. For example, the money, the currency, exemplifies a complex relationship that we have with the matter and with the material. We have to keep in mind that during the Middle Age, the main currency is called solidus, which according to Roberto Lopez is the dollar of the Middle Age. It was created by Constantine I the Great at the beginning of 4th century before Christ. And its stability is associated with the stability of its quantity of gold. So here, obviously, the form does not matter. Let's say the soft part of the currency doesn't matter. What matters is only the hardware, the hard part of the currency, which in fact is simply the quantity of gold. And this lasted for a very long time until the Chinese decided that paper money could replace the matter, could replace the gold. And it's also what happens with bills here in Britain. Sorry, not in Britain, in Sweden here, and what would happen slightly later in Britain. In any case, for some people, this opposition between paper money and material-based money, I mean solid money, or as we could say, is very important. For example, Jefferson, who was not to be considered as a very conservative guy, said that gold and silver coin is the most perfect medium because it will preserve its own level, because having intrinsic and universal value, it can never die in our hands. and it is the surest resource of reliance in time of war. It's kind of interesting, by the way, to connect this to what is happening at the very moment in Europe. Later, before that, sorry, he expressed in a very clear way that how he was opposed to paper money, saying that paper is poverty, it is only the ghost of money and not money itself. So I won't go into detail of this relationship between money and matter, but in any case, it's absolutely clear nowadays that everything we are dealing with goes much beyond the quantity of gold that we can refer to. If we consider a scale here, for example, we see the quantity of silver which is available today in our society. And as you can see, we have so much more of everything else. I mean, the real estate assets are much larger than the quantity of silver or the quantity of gold or the quantity of anything that is material. So it's clear that today we live in a world in which at some point form and software almost in a kind of linguistic way, because I mean the form of a paper money doesn't matter. What matters is the semantics of it. It is the quantity, the mathematical quantity of money that is printed on the check. It really doesn't matter how it looks like. The form of it doesn't matter. So the concept of form we are dealing with at some point in today's society is definitely a linguistic concept of form. It's a linguistic concept of information. It's a linguistic concept of the software issue, and it's not a formal one at some point. So we have, let's say, we have a first opposition, which is between the form and the matter, between the software and the hardware. And we have a second opposition within the software itself, within the concept of form itself, which is a linguistic understanding of form and a formal understanding of form. And obviously, the linguistic understanding of form has become absolutely dominant in today's society. And of course, with crypto money, with Bitcoins and some other forms of crypto money, this opposition has become even more crazy, because it's only the linguistic dimension of the Bitcoin which is giving the Bitcoin its value, even if in the case of Bitcoins, the linguistic dimension is in fact a completely mathematical dimension. So it's a number, but it's not because it's a number that it's not a linguistic definition. On the other hand, the more mathematical it becomes, the more linguistic we could say it is. So matter does something, but if we want to address today what matter is really about, I would say that matter does something it has never done before. It computes. Not only we use computer to create new materials, but we use new materials to create new computers. This introduces a virtuous loop between matter and form, mathematics being considered as pure form, as a pure abstraction which entirely relies on formal languages. This loop is the most powerful relation between that ever existed. Sorry, it's the most powerful relation that ever existed between matter and knowledge. Its strengths and its level of integration go much beyond anything that previously existed in the mechanical age. So this is something we see, of course, with CPUs, where we see an absolutely amazing integration and almost fuse of language and matter in a way that has never been experienced before. We can see this, by the way, when we look at the consequences of this fusion of this fuse between matter and between mathematics, or let's say linguistics, and matter or materials. So we can see this when we look at the amount of derivative and whatever. So today we experience this kind of relationship between tools, matter, and intelligence. It's something that I tried to conceptualize in 2002, so exactly 20 years ago, when I produced this diagram explaining how language, inorganic materials and organic materials are in fact interconnected through the concept of infocapitalism, technocapitalism, and biocapitalism. Infocapitalism being associated also with mechatronics and nanoelectronics, technocapitalism associated with material sciences and intermaterials, and biocapitalism with bioinformatics. And what I said at that time, and I still believe it's valid, is that what matters is really what is happening at the center of this diagram in the part number 7, where integrated science and integral capitalism is playing a role. I was in fact influenced by the reading of the Bauhaus Review in this issue of the Bauhaus magazine in 1928, number 4. As you can see, Ernest Mayr is listing a couple of materials here that were, of course, advanced material at that time. I mean, they are not that advanced material today, but they were. And I really wanted to show that based on this list, the amount of materials that we know today, the brands that are active in material science, and the amazing amount of new materials and new chemicals that we are using today goes in the direction of a complete integration between matter and computation through a kind of linguistic definition. So this is why I came up with this basic list of material to show the evolution between the Bauhaus and what we are experiencing today. So going back to this issue of information, I still believe, I believed at that time, and I still believe that what's very important today is to understand not the matter in a kind of materialist way, in a let's say 19th century way, or let's say according to the 19th century paradigm. It's not only, it's not so much more interesting to consider matter through the eyes of Georges Bataille, who believed that matter was something that would allow us to reach some sort of formless, which I believe at some point is not really true anymore, because matter is part of our linguistic system of production. But I think it's important to understand the relationship between linguistic and matter, the relationship between formal models, including mathematical models, and what can be extracted from the matter itself. And I believe that even if you never really discussed the material issue associated with a transistor, I believe that Shannon had a very deep understanding of that. He mentioned the transistor as quite possibly the greatest invention of 20th century, which, by the way, is probably true, at least at least when it comes to technological invention. So if we make a comparison between, what happens in the 18th and 19th century and what is happening after the Second World War, what we see is that the relationship between matter or materials, because here it doesn't really matter if it's matter or materials. What is important is that this relationship between matter and language in the traditional machines is a non-dialectical relationship. If you look at a classical typing machine, you can imagine building this machine in any kind of material. It's not gonna change much, This typing machine is obviously made of steel, but just imagine you make it with wood, or you make it with gold or whatever. It's not gonna change anything. It's not gonna have a feedback effect on what is printed by this printing machine. So in fact, there's a strict separation. There's a strict, let's say, border, or I don't know what to say, between the matter and the language which the matter is supposed to use or to output or to represent or whatever. And it was a case at the very beginning of the printing era. If you look at the printing press, it's the same. We have the mechanical part of the printing press, the levers, but they have no relationship with the letters. Those things are strangers to each other. And you can build the most crazy printing press in solid gold. It's not gonna have any influence on the nature of what is printed. It's exactly what is not happening with the current mechanical paradigm we are living in, which is the paradigm of the computer. So the movement of levers have been replaced by instructions to perform abstract operations, for example, arithmetical, but ultimately logical. The non-effective printed text has been replaced by code with effectiveness. Instruction, data, code simply become information. And this information is in fact very much dependent ultimately on the way we can use the matter. So for example, if we use electrons and standard gates, electronic gates, we can implement a certain linguistic model. But if we were to use other technologies, for example, quantum technologies, then we might have to change the linguistic model we are using, because we don't have the same logical rules with quantum computers. So in fact, this dialectic, this relationship between the properties of the materials, the intrinsic properties of the material, and the linguistic model or the conceptual model that we want to use for computing is in fact becoming more and more interesting. So when Shannon theorized the theory of information, he was not paying very much attention to that because it was the very birth of the electronic digital computers. And in fact, he was simply interested in understanding the fundamental problem of communication, which for Shannon is that of reproducing at one point either exactly or approximately a message selected at another point. Frequently, the messages have meaning. So when we look at the modern definition of information according to Shannon, this relationship to matter is not extremely present. Still, as we will see, it has become more and more present according to the evolution of computer science and to the evolution of electronics. So when Shannon paid attention to the relationship between matter and the mathematical model, he mostly paid attention to the electrical current, the electrical voltage. So he was not very much paying attention to, let's say, the nature of the material that were used for the production of electrical voltage, but he was also, for example, not even paying use to the atomic scale, to the electrons that are involved in this new science, which is electronics. So he was interested just in understanding the relationship between logic gates, I mean the presence or the absence of electricity, of signal, and the logical rules that were stated a century before by George Boole in the UK. So as you can see here, he proposed analogies between the calculus of propositions and the symbolic relay. And it is another very big piece of work by Claude Shannon, which came before the theory of information, but which was no less influential. So in fact, it was a master thesis of Shannon. And after finishing this thesis, he asked, is there a grand unified theory for communication? In a 1939 letter to Vannevar Bush, Shannon outlined some of his initial ideas on fundamental properties of general systems for the transmission of intelligence. By the way, as you can see here, he was speaking of the transmission of intelligence, but later he was replaced the word intelligence by the word information, which he borrowed from Hartley, and that he considered a much more interesting concept. So in any case, when we go back to this relationship between the matter and the machine not as a mechanical machine, obviously, but the machine as something that can produce some abstract result. What we see is that contrary to what we have here, which is the mechanical Jacquard loom, the relationship between the material and the abstract mathematical model or the abstract linguistic model is of a completely different nature. A lot of people have, let's say, referred to this Jacquard loom as a pre-computer, as something which is a kind of ancestor of the computing machine we are using. I believe that while this comparison is interesting, it has some limits. And definitely the limits, as I said, is that there is absolutely no relationship within this machine between the material nature of this machine and the abstract nature of this machine. So here, for example, we are using paper for the punch card. It doesn't matter. I mean, any kind of material would have worked exactly the same. This machine is made of wood, but any kind of material would also have worked exactly the same. So as I really, as I hope I have demonstrated, the main difference between the kind of computer we are using today and this kind of machine is that in this kind of machine, even if it's let's say an ancestor of the digital computer, this kind of machine is still very close to the printing machine, where the material logic of the printing machine has no influence and no relationship with the conceptual nature of the printing machine. So the material nature and what is printed are are part of two fundamentally disjoint and different logic. And it's still true for these punch cards, etc., etc. So today, the materials are now part of a global financial economy, as we currently experience the financialization of architecture and construction. We also experience the financialization of matter and materials. The status of material has become amazingly complex, either on a scientific, economic, ideological level. These evolutions are entirely reshaping the way we define architecture today. This is what I tried to explain already in my research on the biocapitalist landscape at the very beginning of the year 2000s. So the materials are now part of the global financial economy because matter has become a machine. And when we look at the logic, what we see, for example, is that in the most recent attempt to create a relationship, let's say a material relationship between computation and matter, I think, for example, here in the material computation or the biomimetics paradigm, I think it was a failure at some point. Because when we look at that, this famous diagram by experiment, sorry, by Frei Otto, when we look at that, what we see is not a matter that is doing computation, according to me. It's just a matter that answer extremely basic laws of physics. And there's no way without reprogramming these laws of physics, let's say, there's no way that we can change the behavior of these things. It's the same for subbubble. So the problem with material computation is that at the scale of humankind, it's 100% static. Subbubbles were self-forming 100,000 years ago, exactly as they will do in the next 100,000 years. That's a problem, you know? So maybe there is some sort of computation that happens. And again, if there is some sort of computation, it's nothing else than the computation that is stated by the laws of nature. It's not a computation we can really influence. It's not a computation we can really control, let's say, by reprogramming its linguistic definition, which in fact is exactly what we are doing with a computer. I mean, with a computer, if we change the abstract model of computation, we change the computation itself, you know, which is not what is happening in this kind of natural computation paradigm. So when I refer to matter as machine, I refer to a constantly evolving interaction between the capacity of matter to embed computation and to generate models of computation, the formal models, and our own capability in inventing new linguistic models, which are the logic mathematical models. One can't be genuinely interested in models of analog material computation that hasn't been infused beforehand by abstract and conceptual models of computation. All matter are possibly machines, but some are definitely more interesting than others. So when we look at the matter today, we do it in a way which is fundamentally different to what we were doing, of course, 1 century ago, but also a way which is fundamentally different from what the material computation, which is more or less fashionable in architecture, or maybe not so fashionable anymore. But in any case, we could consider that it was one of the latest trends in materialism in the discipline of architecture. And I think the way we are dealing with matter, when we speak about computation in computer science, in the industry of processors, for example, of chips, is of a fundamentally different nature, because the the dialogue between the abstract models of computation and the capabilities of the materials is a very, very integrated dialogue, which is not the case within the traditional way we consider the matter in traditional machines. So yeah, thanks a lot.
Thank you very much, Philippe. That was extremely enjoyable. Lots to talk about. So we have now time for questions from anyone. So feel free to either use the hand raising function, just raise your hand, or write something in the chat. Any of those options. I can also start by asking something, maybe. So I really enjoyed the way you were talking about this loop between matter and form, and the way it's now more integrated than ever. And from the perspective of someone who works with words and language, I'm a writer. I'm grappling with the question of what does that loop mean for writing, for poetry, for example. And I just wondered if you had any. Does it mean that a poem is now something else? I just wondered if you had any thoughts about that.
I haven't thought about the relationship with poetry, but I would say that, you know, maybe poetry is also a way to catch another kind of, I mean, a very specific relationship between what we say. So the linguistic issue. I mean, part of art, of the production of art, what we say, the semantics, of course, at some point the syntactic part of it as well. But let's say, yeah, maybe poetry is in a very non-rational way. I think it's trying to reframe the relationship between the abstract meaning, the content, and the system which is producing this. But I don't know what is the exact nature of this system. You know, I don't know. I mean, it's difficult to answer these questions, but I think, yeah, maybe poetry is not happy with deeply rational, let's say, relationship between matter and language, but it's also not very happy with a lack of relationship between matter and language.
Mm-hmm.
You know, it's something which is a bit blurry in between.
Yeah, yeah, that's an interesting way, yeah, to think about it. And I don't know the answer to this question either. But yeah, thank you for your thoughts. Okay, anyone else have a question? We have one, Renzo Filinic.
Thank you very much. Thank you very much, Philippe, for your lecture. Very interesting. You remind me a lot about Heinrich Holt. He says his notion of general ecology as a continuum, as a matter of ambient in all the context. In that sense, I want to ask you, because how you can see this notion, or this conception of techno-ecological that we live today, and, that is, of course, of course, is inherent to in the non-ferrite and the bioferrite aspects of how we related with that, the transindividuation, using the notion of transindividuation from Simon Don to how we transindividuate with this these new immaterial matters, as we can say that is information, that you say that is information taken to the notion of Anso from Catherine Hales too, because she related this immaterial, how is matter in the humans, in the society, but we cannot see that. But we can take it in the subjectivity, in the subjectivity of our relations and operations, of course. I don't know if I was a little clear with that, but thank you.
I don't know what, I mean, let's say the relationship, or more precisely the difference I see between, if I consider Simondon, if I consider what he's saying about individuation, not only for objects, but if I focus more specifically on living organism, the main relationship, the main difference between the computers and the humans is that in humans, we cannot easily change the linguistic models, let's say. I mean, the DNA, for example, it has its own rules. So we can change the DNA, but I don't know if we can, and I don't know if we will ever be able to do it. I don't know if we can really change the rules, the transcription rules that are part of the grammar of the DNA. But in an artificial computer, we can do this in a very easy way. We can implement any model of computation. So this is why it's, I mean, this computational revolution of the 20th century is so amazingly powerful, is that we can use the matter as a machine, but contrary to any kind of natural computation models, we can, in a fraction of a second, we can completely change a computation model just by changing the arithmetic, just by changing the rules, by changing the axioms. And so if you want a computer to answer, if you ask a computer, what is the result of 2 + 2? A standard computer will say it's 4, of course. But if you want a computer to be based on completely different rules that will give the answer 2 + 2 equals 5, you can do it in a very easy way. You can implement any kind of computational model in a computer, which is not the case, I think, with the living organism, at least at the very moment. I don't know if it's possible on a theoretical level, but on a practical level, in any case, I don't think it's something that we can achieve today. So yes, what makes the computer so powerful, according to me, it's not the fact that it is digital. It is not so much the fact that it's based on electronics, on electrons or whatever. What makes it so amazing as a piece of machine is that we can constantly change the rules of computation, the logic of the computation, and we can define new relationship between the intrinsic characteristics and capabilities of the materials and the what we know about the formal language and the formal systems of rules. So this is what at least this is what I'm very much interested in. I don't know if Simondon, I mean, I haven't read Simondon for quite a while, I have to say, but I don't remember if Simondon was really paying attention to that, I think. I don't think that Simondon was really paying attention to the fact that we can embed any kind, and I mean, many different models of computation into a material system when we use a computer. And I think this is the most interesting part of modern computation. And this is why I'm not so fascinated by what we call material computation, because what we call material computation, in most cases, it's extremely deterministic. I mean, you cannot ask, you know, the subbubble. You cannot reprogram the subbubble so that they will behave in a different way at some point. At least, at least if you stay in a material computation paradigm, in a natural computation paradigm. If you jump into an artificial natural computation, so it's not natural computation, it's artificial computation, then of course you can imagine that the subbubble will behave in a different way. But if we stick to the natural computation, which in fact is a kind of hidden, let's say, definition of what people call material computation, then if you stick to this natural computation, then the subbubble that were appearing as I said, I mean, 100,000 years ago, they will be exactly the same in 100,000 years. And to be honest, I'm not very much interested in what's going to be the same as today in 100,000 years. By definition, because I know it's going to be the same. So how can I be interested in that?
Okay, thank you.
So yeah, I think Simondon didn't speak about that precisely.
Nope.
Anyone else have a question? Vera?
Yes, of course. Thanks, Philippe. This was I really enjoyed the lecture. I greatly appreciate the scope and the curiosity that is so vibrant in the way that you always make constellation of things. The one question that I would be most interested now is to hear. So you, in your answer now, just now to Renzo, you were suddenly speaking of grammar and of transcription, whereas before you were kind of making the polarity between formal language and mathematics on the one side and linguistics quite generically on the other. But the one thing that in my research I'm very much interested in is to find it. So what do we do with code? Because code is at work in linguistics. It's at work between cardinal and ordinal numbers, for example. It's at work in algebra. It's at work everywhere. How would you address or attend to the status of code itself in the way that you were making this link of matter as machine?
In fact, I didn't really mention the code because for me, everything which exists, which can be considered as a linguistic construct, including mathematics. I mean, the whole of mathematics, it doesn't really matter if it's algebra, arithmetic, logics, etc. All of that is of a linguistic nature, and everything which is of a linguistic nature is ultimately code. So I didn't really make an opposition between mathematics and linguistic, for example, because mathematics is just a part of linguistic, and linguistic is part of code. So I would say if I would have to make a kind of diagram, I would have a very big circle, which is code. Within this circle, I would have linguistic, and within this circle, I would have different things like mathematics, I mean, formal languages, natural languages, etc., etc. So yeah, code for me is everything. Everything which is not material is code. And yeah, I mean, you know, a natural language is code. If you don't learn the rules for decoding the natural language, if you don't learn the rules for decoding German, German will appear as cryptic as a cipher.
Yeah.
So this is why I believe it's nothing else than code.
Yeah. But then is it important to you that linguistics, I mean, in the strict sense, it implies a generality, a level of general linguistics. Now, otherwise we have things like philology, we have things like semiotics, not semiology. So then it gets much more, let's say, less formal, no, less hygienically formal. Then what we have is the general paradigm of linguistics. Do you mean it in that sense, or do you speak in a more metaphoric, extended sense of linguistics?
No, it's not. It's not metaphoric at all. But I don't know if there are some universal or, let's say, shared rules for the linguistic. I mean, you know, we can agree with some hypotheses by such or such a linguist, like Chomsky or whatever, saying that there are some common characteristics between languages, etc. But even if there are some common characteristics between languages, there's always something we need to learn. There's always something we need to decode at some point. You know, of course, there are some common characteristics on a syntactic level between, for example, French and Italian, you know, but still, there's a lot of things we need to learn. So this is why I'm not sure that we could say that there exists any kind of absolute, let's say, translatability between everything. At least something that would be perfectly formalized. I mean, in a mathematical way. I mean, probably if we can do it, in any case, it will be done in a purely mathematical way, of course. But then the translation rules can become as numerous as the language itself, which is not not very interesting at some point. I mean, not very useful. We can always translate everything, but then the rules of translation can be as numerous as all the possibilities that exist in a purely combinatorial way. You see what I mean? So then it's not it does not correspond to what we are looking for when we look for generalities. I don't know if it answer your question, but yes, I mean, again, I think everything is code, but I don't consider code in just for computer languages or whatever.
But let me try from another angle, perhaps. So then code, precisely because it's kind of putting limits to the arbitrariness, not that you were just now saying, it has a relation to generalities. Can you speak about this relation, how you think of it? So is it, because it seems to me a bit of a chicken egg problem, but I have the impression it's not for you, and I'd be very curious to hear how.
I don't know what is the relationship between code and generalities. I don't know if we can find generalities for everything. You know, it's I don't know how to explain that, but for me it seems to be an open question. You know, can we? It's a bit like what happens in the laws of nature in physics. I mean, can we reduce all the phenomena that are that we experience? Can we reduce that in a couple of mathematical equations? I don't know. I mean, maybe the mathematical equations we have are just a very basic approximation of the complexity of the natural phenomena. So maybe the generalities that we could extract from all, I mean, the different kinds of codes, maybe they are just, I mean, a not so bad approximation of the richness of codes. You know, I don't know. It seems to me that what you have in mind when you speak about generalities are some sort of abstraction, some sort of reduction. But I don't know if we can reduce everything. If we can reduce everything, it means that we will be able ultimately to understand all the laws of nature. And I don't know if we will ever be able to do that. I don't know if we can reduce the complexity of the real to a few formulas. And I don't even know if we can reduce the complexity of the real at all.
No, my question is with the generalities, it's an epistemological point of view, which is also how you are now answering. So what I'm interested in is to say that there's a physics point of view. No, so the way I see it in physics is precisely what you are now describing. So physics will never, I don't believe physics will ever exhaustively and correctly describe all of nature. But what it does describe is formal, it's mathematical, it's of a general. In the German we have a distinction. We have generell und allgemein. In English we can't distinguish that, which is a problem, because the allgemein is almost like universal, but it doesn't mean it's uniform for that matter. It's more, it's accountable to everything, whereas general is accountable to a certain order, to a certain classification scheme. So this distinction is always missing in the English. And the what physics does is it produces allgemeine Sätze, but they don't claim to exhaustively rationalize all of nature. And this physics aspect with respect to code is what I'm very interested in. So that's not primarily an epistemological point of view, but an active one, I would say. I'm not sure if I can make this clear. Perhaps I also don't want to
no, I don't know if I understand perfectly what you have in mind, but for me, it seems to me that you consider code as something, again, which in a kind of reductionist manner, you know, as something which is shorter than what it's referring to. But I think code is referring to itself, you know. I don't see code as something else. For example, yeah, I don't know how to explain that, but for me, a natural language is just a piece of code, you know. And at some point, we need a certain amount of rules to decode what we say through natural language. And if we have enough decoding rules, then we can understand. If we don't understand, and in many cases we do approximation. So I think to decode everything, we need everything. I don't know how to explain that, but it seems to me that what you have in mind when you speak when you speak about code is something of a kind of reduction. What I have in mind when I speak about code, it's not a reduction, it's a system. It's a logics, you know, it's a logic, it's a system. It has nothing to do with reductionism or whatever.
Yeah, thanks. That made it clear how you are thinking of it. Thanks a lot.
Okay, there is one short comment in the chat from Renzo in relation to this, saying we can see code as Derridian difference, maybe. Don't know if you want to comment, Philippe?
Maybe, I don't know.
I was thinking in that in the moment that you explained in this, but I understand your last point that it's clear now with everything that you say. It's not given the semantic aspect, just the operational. The operation is the thing here. The operation behind this, the whole systems. I taken this because sorry again, because I taken the example here in Chile when we have the cybernetic example in the 70s in Allende's, you know, with the Stanford beer, and he made the cyber scene with codification, all the economy and all the social aspect of the whole country, like using the code for reorganizing the whole country at that moment. Of course, we don't see how it works because we know the history, but in the moment we have the planification, all the formulas he using in that time.
In fact, we know that with a couple of parameters, we can describe. I mean, in most of what we are doing, we know that we can go towards an arbitrary, towards a description of more or less everything with an arbitrary precision. But the problem is that to reach the ultimate precision, you need to know, you need everything. So the problem is when do we stop? And in most cases, we are happy with really good approximations. This is what science is all about: good approximations, really good approximations. But it's not about the truth. It's not about the real description of what is happening. It's about high quality approximations.
Anyone else have any questions? I think we are meant to finish at 8, actually. I'm not sure, but if, yeah, just giving people the chance. If not, yeah, just left to say thank you very much, Philippe. Great talk and nice discussion. So thanks all.
Thanks a lot.
Thanks a lot.
Thanks a lot again for inviting me, and yeah, it's I was happy to answer your questions.
Mm-hmm. Thanks. Bye-bye.
Okay,
Thanks.
a lot.
Bye.
Bye-bye. See you next time. Bye-bye.